All right, welcome. In this video, I'm going to be telling you about the derivatives of exponential functions that aren't e to the x, like 2 to the x, 3 to the x, 5 to the x, 10 to the x, a to the x in this case. I'm going to show it to you in general, because maybe in my class you heard me mention that the derivative of 2 to the x was 2 to the x multiplied by log of 2. Or maybe you were just curious, what happens, in my class talk a lot about e to the x or e to the something else, but not a whole lot about 2 to the x. Maybe you're just curious. So what I'm going to do is I'm going to say, all right, I need you to recall not really, I wouldn't call it a log property, I'd really call it like a fundamental identity of a logarithm. That if the log of a exists, then we can say that a is equal to e to the natural log of a. And I think a lot of that has to do with your ideas of, well, what's the domain of natural log, right? We're not going to be able to take the natural log of 0. In this class, we're only going to be interested in positive numbers. There are definitely ways we can take e to a power and get back a negative number, but that's going to be on the scope of what we do in AP Calculus. That would be in the next course. So a is going to be e to the natural log a, right? So I could say that a to the x is equal to e to the log of a to the x. But this is the type of situation where we multiply these exponents, right? So I'm going to say that's e to the log a times x. Okay. Now, if I wanted to take the derivative of this, that would be, well, the derivative of this thing. Right? And log of a is just some number, right? If a is a positive number, log of a is just going to be some other number. It might not be positive, but it'll definitely be a real number. And what else was I going to say about that? Oh, if this was e to the, say, 5x, we'd know exactly what to do. We know how to take the derivative, right? Using the chain rule. We'd say the derivative of e to the 5x is e to the 5x multiplied by 5 for the chain rule. So I'm going to say that this is e to the log of a times x times the log of a for the chain rule. And then I'm going to apply this log property or log identity in reverse. And I'm going to say, well, I could say that this is e to the log of a to the x multiplied by the natural log of a. And then e to the log of a, that's a, just undoing what I did at the beginning. So this is a to the x times natural log of a. Or, as I wrote it up there, natural log of a times a to the x. Okay? And that's where we get this formula for the derivative of an exponential function that isn't e to the x.